So we've talked about the concept of a celestial sphere, the model of a celestial sphere, that all the stars are actually at the same distance from the Earth, and the Earth spins in the center of this hollow sphere we call the celestial sphere. It's a model. But kind of related to that, we need to be able to, from our own perspective, describe what we call the local sky. Okay, now the local sky is different than coordinates on the celestial sphere. The local sky will depend upon what longitude and latitude you're at and what time of day you're at. There are all sorts of programs out there that can anticipate, you can use a sky map to anticipate for a given location what the local sky will look like. So there are times, for instance, this gal is pointing to an object here, perhaps the sun, and she wants to be able to relate to somebody where that sun is on her local sky. Now, the sun is going to change its position as the Earth rotates, but she needs to be able to say what that is. So, one important aspect of locating an object on your local sky is the altitude. So what she does is she puts a line out to the horizon, then she puts another line towards the object, and the angle that makes is the altitude of that object. Another thing, she's not quite done, right? She needs to go ahead and also describe where it is north, south, east, and west. And I see that my slide somehow it got deleted, but she needs to say, and there's different ways to say with regard to the north, south, east, west direction where an object is. But your textbook with this figure just simply says this object is located southeast. You can also use angles and things like that. So I also want to point out some other important things in your local sky. So when somebody talks about their zenith, they are talking about a location right overhead. That's a person's zenith. The horizon, of course, we kind of talked about horizon. You need it to say what sort of altitude an object is. But the horizon basically is in all directions going out that way. There is one important line called the meridian. And the meridian, you need, in order to identify the meridian for a person in their local sky, you need to understand where the zenith is for that person, the due north and due south. So this line right here is the meridian, okay, for that person, local sky. So also related to the local sky, sometimes we want to be able to point up at an object and say either, for instance, how far objects are apart, or how big an object is, or, for instance, how, like that 60 degrees angle. Okay, we want to be able to kind of estimate that. And so there's this nice convention. So, for instance, that 60 degrees altitude for the sun, we should be able to take our palm and extend it, or take our arm, extend it out, and our palm from thumb to pinky is about 20 degrees. So it would have been about 3 of these to go up to the sun. Alternatively, if a little bit smaller angle, our index finger is kind of handy. It marks 1 degree. And last but not least, we have a 5 degree from knuckle to knuckle. Okay, so to kind of put that in perspective then, I mentioned we can say what the distance is between objects. So this figure right here actually is honing in on the asterism, the Big Dipper, and looking at the pointer stars, the 2 farthest pole stars, and they are about 5 degrees or a half of a knuckle to knuckle. Okay? We say that we sometimes use the word subtens. Subtens. Okay? So we would say that these two, I think that's what I want to say. We would say that the distance between these, or maybe not, is 5 degrees. I think subtens is reserved for this. Let me show you one more figure from your textbook. Okay, this is another handy thing. We might kind of extend our arm, and if you hold out your index finger, remember your index finger is supposed to be about 1 degree. Okay, so So if you hold out your index finger, honestly, I know it seems kind of strange, but your, how do I say this? Your index finger would be about the diameter of 2 moons. The disk of the moon, okay, is, now we say the moon subtends 1/2 of a degree. Isn't that amazing? So one of the things I think we should all go out and try is that, and you can do a little bit of looking into this, but if you're like, hey, I think the moon's a lot larger when the moon is rising or the moon is setting. It just is a lot larger when the moon is just off the horizon. And actually, if you do a little bit of looking into it, it's an optical illusion. Our mind is playing tricks on us. So to kind of take the trickster out of it, we should all go out, and when the moon is just rising, we're going to have a supermoon coming up in September, we should see if it just, what we say, subtends 1/2 of an index finger when it's low on the horizon, as well as when it's at near our zenith overhead. So, just a thought. Okay, so we are all pretty familiar with, and now I see I didn't bring my builds in here, but let me kind of describe what this is. We are all familiar with this fact that in a circle there are, with regard to degrees, 360 degrees. Okay, now each degree can be broken up into minutes. So there are 60, what we say, arc minutes in 1 degree. Okay, and each minute, represented with the little dash there, each minute can be broken up into seconds. So there are 60 arc seconds in 1 arc minute. Pushing up. Okay. So here's the deal then. We can look at an object, okay, and we can get a sense for what we say its angular size, the angle that the object subtends, okay? So here's the deal, and I bet you buy this, that, let me scoot this over, that the closer an object is, okay, the closer an object is, the larger of the longer of a larger angle it subtends. Okay, here's the same object with the same real size. Here it subtends, let's say, right here when it's close, the blue. Okay, and when it's farther away, it subtends this pink one. Same object. So here's the deal: the angle is directly related to how far away the object is. The angle is directly related to how far the object is. Okay, so this is quite handy for objects that we really can't necessarily visit. If you're familiar with solving equations, you know that if you have one equation, like we have a relationship here with kind of 3 unknowns. We have the angular size of the object in the sky, we have how big it really is, and then we have the distance to the object. If you know 2 of those things, you can get the third. One equation, one unknown. So let's just say that we can always kind of tell the angular size, how much an object subtends in our nighttime sky. And then let's say, for instance, that we know the distance, then we can get to the physical size. Or if we know the physical size, we can get to the distance. So again, I don't have you do any math in this class, but we might refer to this later on.